As early as 2019, the U.S. Department of Defense Security began to promote the M1A2T main battle tank export plan. It is expected to reach a $2 billion military purchase order. Although the relevant plan has been delayed again and again, at the end of September this year, the internet finally reported the news about the M1A2 tank again. It is expected to be handed over to customers soon and become another type of road equipment in the Western Pacific region. According to the U.S., the tank closest to the M1A2T is the M1A2S EPV3. Today, we will talk about the potential of the M1A2 tank based on the M1A2S EPV3. According to the previous statement of the U.S. Department of Defense Security, the upcoming M1A2T tanks will use FMS export armor instead of the previously used oil-free armor, as well as the non-Israeli-produced battle tank active protection system. Other aspects are consistent with the M1A2 SEPV3. So the point we need to pay attention to is the impact of these changes on the M1A2T tank. After replacing these two configurations, will the performance of the M1A2 tank rise or fall? What kind of equipment can be replaced later? And what level of combat protection can those configurations with the same M1A2S EPV3 provide to the M1A2T tank? First, let's look at the oil-free armor. Those of you who have heard of the oil-free armor before know that the so-called oil-free armor is the low-release oil left over from the refining of natural oil as a nuclear fuel 2350. Its main component is 238 oil. The density of the oil-free armor is very high, about 2.5 times that of the previous one and 1.7 times that of the previous one. This makes the oil-free armor combined with other alloys a highly dense material. Under the same material volume, the density and hardness of the oil-free alloy will even be higher than that of the non-alloy. The United States, as a nuclear technology powerhouse, has long noticed the potential application value of oil-free alloys. In addition to manufacturing oil-free armor to better penetrate enemy tanks, American technicians in the 1980s also came up with a better use for oil-free alloys, which is to make oil-free armor. Since oil-free alloys can be processed into bullets, why can't they be used to make tank armor? In the United States and around the world, the first tank with oil-free armor is the American M1A1 series. Of course, not every M1A1 has oil-free armor. At first, only the M1A1-HA heavy armor version was the first batch of oil-free armor users. Compared with other M1A1s that use composite armor, the defense power of the heavy armor tank has greatly increased. In the face of enemy armor shells, oil-free armor can effectively resist bullet penetration, completely reducing the risk of the tank being penetrated. And even if oil-free armor does not occupy more body structures, it can also provide heavier protection for the tank, increasing the density, making oil-free armor better absorbed and dispersed by impact energy, thereby reducing the damage to tank personnel and equipment. Although the U.S. has still kept oil-free armor technology secret, we can also infer the convenience of U.S. development and equipment for oil-free armor from the characteristics of oil-free material itself. First of all, for the U.S. the processing process of oil-free armor is not complicated. The so-called oil-free is that the oil mine extracts the remaining negative products after 235. The main component is 238 oil. In the past, it was generally processed as nuclear waste. For nuclear weapons and nuclear power plants like the U.S., the cost of obtaining it is not high. Therefore, oil-free armor is not unacceptable in terms of manufacturing cost. In addition, oil-free armor is also very useful for the U.S. The U.S. has relatively few oil-free mineral deposits, so it is a good alternative for the U.S. to use the relatively easier-to-obtain material of oil-free armor, and it is also a stable trade. Since oil-free armor has so many advantages, if the M1A2T tank does not have equipment, will it be a kind of configuration downgrade to use FMS armor instead? In fact, this view is not true because even the U.S. tank will not install all oil-free armor. Oil-free armor itself is not a perfect configuration. Whether to use it or not depends on the user's needs. In fact, even the U.S. Army did not stipulate that the tank must use oil-free armor for the next generation of main battle tanks, M1A3. In the eyes of the U.S. Army, combined power-enhancing power propulsion technology more powerful new main guns, and AI artificial intelligence technology are all functions that the next generation of main battle tanks should have. Smaller thermal signals and electronic features can also improve the tank's survivability in the future. As for oil-free armor, it is not an indispensable thing. And when oil-free armor is curved, it is much more difficult than ordinary alloy armor. If it is directly processed into flat material, it will be more suitable for the front of the main defense. But for tank operators outside the U.S. Army, the processing process of oil-free armor and later maintenance may also become a problem. Because of this, M1A2T tanks are made of composite armor, such as alloy, ceramic, etc. Instead of heavier oil-free armor, it can also maintain a certain level of protection while improving the original mobility of the tank. As for the lack of an Israeli-based active defense system, it is no longer a problem for M1A2T, because there are actually many replacements of the same type. The so-called APS active defense system is a system that is installed on the tank to actively counter the enemy's anti-tank weapons. This system is divided into two types. One is soft kill, and the other is hard kill. The so-called soft kill protection is to provide a signal shield for the tank to make it difficult for the enemy's anti-tank missiles to lock onto the tank. Whether it is to release smoke to achieve a concealed purpose, or to use radiation devices, laser detectors, and infrared detectors, as long as it interferes with the operation of the enemy's weapons, it can be regarded as soft kill defense. However, the Israeli APS active defense system is a hard kill defense system. This system is to release explosive fragments or other interfering props to intercept the enemy's weapons. If the enemy's missiles mainly rely on large power to hit the armor, then this type of missile disrupts the flight trajectory and the original armor ability will be greatly reduced. If the enemy launches a high-explosive anti-tank missile that can shoot holes to achieve kill, then this problem is easier to solve. As long as this missile loses the best detonation interval and cannot release the ideal metal shooting current, it can protect several tanks. This type of hard-kill active defense system has been developed by many countries. Therefore, the M1A2 can be used by the United States ARTIS Ironwood system, German ANP system, and South Korean KAPS system. This system will be applied to the improved version of the South Korean K2 Black Panther tank. Speaking of which, the big soldier also thought of another weapon. In fact, tanks similar to the M1A2T and the M1A2S tank previously exported to Saudi Arabia by the United States. Due to the earlier export period, the M1A2S tank was mainly modified on the basis of the initial enhanced tank of the M1A2SEP. And the biggest modification of this tank was also on the armor. The M1A2 tank did not use oil-free armor, but replaced it with other composite armor. The reason for this situation is that in addition to Saudi Arabia, because of technical problems, it is not very convenient to maintain oil-free armor. There is also a very important aspect, that is, Saudi Arabia's geographical environment and potential imaginary enemy. Saudi Arabia is a desert country, and there are few rivers and lakes in the country, and there are few wetlands. In the vast desert, the mobility of the tank must be listed as a priority, so using heavier oil-free armor is not a perfect choice. Not only that, Saudi Arabia's potential imaginary enemy is also not outstanding in anti-tank capabilities. It seems that it is also a little wasteful to install oil-free armor. First of all, the high temperature in the desert and the sand environment are increasing the load on the M1 tank engine. Long-term operation in the desert will speed up engine components wear and tear. This will not only increase the engine oil consumption, but also affect the mobility of the tank. Therefore, from an environmental point of view, the M1A2S tank should be listed as a priority. And in the current international situation, the most likely country for Saudi Arabia to use tanks is Iran. Although the two countries do not directly interact on land, they only have a 200-kilometer-wide Persian Gulf. The part of the Hormuz Strait is narrower. Although they are both Islamic countries, Saudi Arabia, which is the leader of the Sunni forces, and Iran, which is the majority of the Shiites, actually have a lot of contradictions. In addition to geopolitical considerations and historical war factors, the relationship between Saudi Arabia and Persia is not good. In the situation of Iraq, Syria, Yemen, Saudi Arabia, and Iran support each other. Different political forces and armed groups form an agent conflict. If you look at the strength of the M1A2S tank from the point of view, you will find that refueling armor is not a must. After all, the strength of the Iranian tank force itself is not good. Not only that, we can also see the firepower advantage from the main gun advantage of the Saudi M1A2S tank. At present, the main equipment of the Iranian tank is the domestic Kalal main battle tank and some T-72 series tanks. However, the Kalal tank, which is said to be domestic, is actually also the domestic upgraded version of the Kalal tank. The tank was officially unveiled in 2016. Speaking of which, it has a lot of upgrades, including a light-emitting fire control system, a laser rangefinder, and a ballistic computer. But if you compare it with the Saudi M1A2S, the soldiers think that the upgrade in the main weapon is not big, because the Kalal tank is still the 2A46 125mm anti-aircraft slide gun designed by the Soviet Union in the 1970s. Although this main gun has also undergone some improvements, Iran has not followed the same upgraded main gun of the Russian T-90 tank and considered the military production process in Iran. In addition, the main gun of the Kalal tank does not have any significant improvements. In order to accommodate a larger volume of 125mm anti-aircraft gun, the Soviet Union used an automatic loader and a separate ammunition design. This loading method makes it impossible to fire a long-barrel shell-removing armor-piercing shell like the T-72 and T-80 tanks with a length of about 730 millimeters and cannot use long-barrel armor-piercing shells similar to those of Western countries. Additionally, the 2A46 gun does not have sufficient shooting accuracy due to design limitations and various technical factors affecting its operation. This takes into account the potential issues with components, ammunition quality, environmental conditions, and the stability of the targeting system. For example, the 2A46 main gun had a problem with the anti-aircraft gun in the US and the UAV in the Russian T-90 tank. The 2A46 gun has a problem within the US and in the Russian T-90 tank. For example, the 2A46 main gun has a problem with the anti-aircraft gun. The M1A2S used by the Saudi Arabian Army is the M256 main gun, which is the same as the US-made M1A2 tank. This main gun is the US domestic version of the German Rheinmetall RH-120 main gun. It uses a high-caliber design, which can give the launch of the missile a higher flight velocity. After the launch of the missile, it will have a powerful mobility, which has excellent destruction effect when it hits the enemy's tank armor and solid targets. And the U.S. military attaches great importance to the weaponry of the tank main gun. It can launch a variety of types of ammunition, including high-explosive ammunition, and artillery-guided missiles. At the same time, the M256 main gun is also in line with the L-44 main gun of Germany. It can launch the Stanig 4-385 ammunition, which is standard for NATO. This means that in the NATO system, the M256 can use the same ammunition as other NATO allied tanks that have the same caliber gun. Different types of ammunition can meet the needs of different combat missions, enhance the combat effectiveness and versatility of the tank. For example, in urban combat, it can use high explosive ammunition to threaten the enemies hiding in the buildings. And when launching a long-range attack, the missile can provide a longer range and a higher accuracy. Not only that, but the M1A2S and the M1A2T that are about to be shipped will be produced locally in the United States and then packaged and exported. Therefore, these two tanks will have the same level of craftsmanship as American self-propelled tanks in terms of main gun configuration. Take the M1A2 tank main gun as an example. The M256 gun uses a cold-pulled no-hole tube technology and is equipped with a Duggar lining. This manufacturing process improves the strength and durability of the gun. Even if the gun has been in use for a long time, it can maintain its original stability and reliability. Not only that, but this design also helps reduce friction between the gun and the inner wall of the gun and improve the accuracy of the gun. As for the performance of the M1A2T tank, what other highlights are there? You are also welcome to add in the comments section. After understanding the M1A2, the next equipment information column will let us pay attention to the Patriot anti-aircraft missile. The news of leaving the land to board the warship and becoming a new weapon on the ship. Thank you for watching video. Like and subscribe my channel. See you next time.